user you're currently logged in as. Now let's try this from the shell where sample.txt exists. And this will attempt to copy the file to remote system. Now we made one mistake. We left off the colon at the end of the copy process. This colon tells SCP, but we're finish indicating the target. Let's try that again. Otherwise, what ends up happening is a copy takes place. When you do this, you're prompted for a password, and at this point, of course, we have to indicate the right password. If we specify an incorrect password, then obviously the communications will fail. But if all goes well, we see a quick non-interactive copy followed by percentage information, kilobytes per second transfer rate, the elapsed time, the number of bytes, etc. This file is copied within an unmeasurable or immeasurable amount of time, which is why there isn't any useful information for the transfer rate and the elapsed time. So this file now exists on that remote system, Linux CBT Media 1. We can confirm it in the user's home directory by searching for it, and there we see it. A cat of sample.txt reveals that it exists. And if we compare the date stamps, timestamps, you'll see that it was copied recently. So it's very easy to copy a file to a remote system. You may also indicate a different directory on the remote system. For example, let's say in Linux CBT's home directory we make a directory test RH5, and it already exists. So let's look at test RH5 to see what's there. It contains a few items. So we'll copy the file into this directory using SCP. Very easy, very straightforward. And it exists on the local system, not the remote system. Let's try that again. It doesn't exist on the remote system. So we'll rerun that SCP command, and after the colon will indicate the directory test RH5, which is relative to the home directory. When you use SCP, it copies by default to the user's home directory unless you specify an absolute path such as / test RH5. Otherwise, anything indicated after the colon is relative to the home directory. So let's indicate the password once more. And tells us test RH5 is a directory. And let's try it again. And now it copies it. With the / it attempted to copy sample.txt as the file name test RH5. Without it, it doesn't throw an error. And there we see it as test RH5. Now, again, this may seem a little tricky, but what's happened in this case is instead of placing the item into test RH5, it's copied the file as test RH5. So if we cap the contents of test RH5, you'll see that it contains 1 through 10. Let's remove rf test RH5, and now let's make a directory test RH5 and try it this time with the / to see how the behavior differs. We'll authenticate. And now the file has been copied as sample.txt into the test RH5 directory. That's LSL, and now we see it's in that directory. So again, it's all relative to the home directory unless you include the absolute path symbol, which is the /. So SCP is an non-interactive copy program. It may also be used to copy files from a remote system to a local system. So for example, a variation on this would be to copy Linux CBT at Linux CBT Media 1 test RH5 sample.txt to our local directory as, let's say, sample2.txt. This will copy the file from the remote system to our local system, providing we authenticate correctly. And it will search the subdirectory test RH5 for the file and place it locally as sample2.txt. And there we have it. And if we cap the contents of the file, it should come as no surprise that it contains 1 through 10. So use SCP as a non-interactive copy program which makes use of SCP. Now, one other thing we should note is that every SSH client supports a debug option. If you are experiencing connectivity problems with an SSH client, you should enable the debug option using -D. That turns on debug and allows you to specify the verbosity of debug, which returns information to the screen. Also use -V, either or. So SSH with the same item dash V being the option, not dash D, that is. So SCP-V, or a number of V's, will turn on verbosity depending on the number of V's indicated. And it prompts us for authentication. If we scroll up towards the top of this output, we'll see the communication stream between the client and the server. Here we see the version of OpenSSH, the fact that the client read the global client config file ssh_config. It read options from the section labeled with asterisk, which means it applies to all SSH clients. It connected using IP version 6 address 2002.4687 DB25 on the third network 20A, embedded MAC address port 22. The connection was established. It searched in Home Linux CBT for identity information to attempt a passwordless login, but none or no identities were found. The remote server's version of SSH is 199, running 4.6. It's packaged as 4.6 on the SUSE box. And other useful information regarding which encryption algorithms were tried and agreed to, whether or not a key for the remote system was found in known_hosts, and it was, which is why we were not prompted, etc., etc. At this point, we're prompted for a password, and once we've authenticated, we'll see more information regarding the session and the termination of the session, including bytes transferred, amount of time it took, so on and so forth. So using -V, you can enable verbosity. So let's just note that. Use -V with SSH clients to enable verbosity, especially for troubleshooting. Now, before we spend too much time on SCP, let's move on to SFTP. The usage is like FTP, or File Transfer Protocol. SFTP followed by username at hostname without a terminating colon will attempt to connect us to the remote system in interactive mode. Again, all transmissions are secure. Let's reset the buffer and then attempt SFTP into the remote system. There we're prompted. We'll indicate the password, and once on, and we'll try it again. Once on, we're prompted with an SFTP prompt, or we're presented with an SFTP prompt. This interface functions like FTP. If you type help, you'll see commands that are very similar to FTP, such as ls to list the contents of the remote system, or cd to change into, let's say, the test RH5 directory, or LSL to list the items in long format, or get or mget to download a file to a local directory, for example, or put to put a file to the remote directory after you've executed !ls to see what's local, for example. So input test 1,000,000.txt, which is a file that exists locally, will allow us to upload the file, which includes transfer information, etc. And this is an interactive client with feature sets like FTP. We can set masks, we can look at our local working directory, so this prints the local working directory. We can change the local directory or the local working directory using LCD, and so on. So use SFTP if you need to interact with the remote SSH server. It requires SSH, not FTP. That's how it works. Again, it's an interactive client. Now, the basic SSH client is used for obtaining a shell. SSH followed by a similar credential set will allow us to interactively connect to a remote system. This will assign a TTY. We'll clear screen and SSH, authenticate as usual. Now we have a session on the remote system. We were assigned sudo terminal number 7. This is a full-fledged session. We can interact as if we were physically at the remote system. We log off, and let's say we want to execute a command non-interactively on the remote system using SSH. Simply execute SSH followed by space and optionally between single or double quotes or without quotes the command that you'd like to have executed on the remote system. So what if we wanted to check the uptime on the remote system? We'll execute uptime And this will be executed on the remote system with the output sent to our local system. Again, this will force us to authenticate. And instead of being granted or allocated a pseudo terminal, the command executes and the output is returned to the local system. We can confirm as much by executing a different command such as hostname. And again, it prompts us for authentication, which is expected, and the return value is the hostname of the remote system. So SSH can be used to execute commands on remote systems using double, single, or no quotes whatsoever, even if you have options to pass in on the command line. Let's try it without quotes. But ideally, to ensure that the shell doesn't interpolate any of the values indicated, you should use single or double quotes so that the values go untouched to the remote system. So we can execute commands using SSH. This is a shell-based client that has the function, the ability, the feature set, the capability to execute commands on a remote system. Now how about SSH copy ID? Well, before you can copy an ID, you need to generate a key pair. On our local system, if we navigate into our hidden SSH directory, let's navigate into SSH, we'll see whether or not a key pair is already defined, and there we see we already have a key pair. So what we should do is generate a key pair as a user who does not have a key pair generated, such as root. Let's find a root shell on our local system. We'll SU in, and we'll navigate into root's home directory into SSH. And as we see, even root has a key pair defined. So the ideal thing to do at this stage is to define a user account, or use a user account such as student 1's user account. Let's SU in as student 1. Rather than removing the key pair that already exists, we'll navigate into SSH, which doesn't exist, which tells us that there is no key pair. So as student 1, we will generate a key pair using SSH keygen with type RSA. Now, it isn't mandatory that you indicate type RSA. SSH keygen supports multiple types, including RSA and DSA, used for version 2 of SSH, and RSA 1 for version 1 of SSH. SSH keygen with help will tell you what's supported. However, it comes back, it's ready to generate the key pair, and by default it generates RSA. So if we kill this process and man SSH keygen, as it is a Perl script, and it throws an error there. So we'll just move forward in SSH keygen type RSA. This will attempt to create a public key, private key pair, RSA key pair. You could indicate DSA or RSA1. Those are your other two options.